Hello everyone, welcome to another video by Knowledgeification. Today we'll be continuing the chapter Dynamics. Let's look at today's objectives. Today's objectives are Newton's first law, inertia, types of inertia, mass and inertia, and momentum. Let's jump in. Now let's picture a ball on the ground. There are two forces acting on it, gravity and an equal and opposite net force. So let's say a person kicks a ball. An external net force is added upon to these forces and the forces get unbalanced. So the ball starts moving. We can take this example and explain Newton's first law. So we can say that Newton's first law is every body continues to be in its state of rest or uniform motion along a straight line unless and until a net external force acts on it. Thus, one can conclude that force is a physical quantity that can change the state of rest or of motion of a body. This property is also known as inertia. Sometimes Newton's first law is also known as Newton's law of inertia. The property of a body to continue in its state of rest or uniform motion unless acted upon by an external force is known as inertia. This is the concept of inertia. Now let's discuss the types of inertia. There are three types of inertia: inertia of rest, inertia of motion, and inertia of direction. Let's discuss each one with detail. Inertia of rest. It is the resistance of a body at rest to change its state of rest. For example, when books are piled up one above the other and the lowest book is suddenly pulled out, the rest of the books remain intact. This is due to the inertia of rest. Inertia of motion. If a body is in a state of uniform motion, it continues to remain in the same state unless an acted upon an external force acts on it. For example, when a boy who is running and is tripped by a stone, he falls because his feet comes to a rest, whereas the upper portion of his body continues to be moving forward due to the inertia of motion. Another example could be when a bus stops suddenly, we tend to fall forward, but the rest of our body tends to be at rest. Inertia of direction. It is an inability of a body to change its direction on its own. So if we're driving in a car and we take a sharp turn, we see that we fall in the opposite direction of the turn. That is an example of inertia of direction. There's a simple relation between mass and inertia. If more the mass of an object, the more the inertia of the object. So, for example, if a football is kicked, it moves a long way, but if an iron ball is kicked with the same force, it does not move as far as the football. So we can say that more the mass, more the inertia. Moving bodies possess a physical quantity associated with their motion which determines how much force is required to bring them to rest. This quantity, which depends on the mass and velocity of a moving body, is called momentum, and it is defined as momentum equals mass into velocity. Since mass is a scalar quantity and velocity is a vector quantity, momentum is also a vector quantity. If a body is moving along a straight path, the body possesses linear momentum. Units of momentum. The CGS unit of momentum is 1 gram into centimeters per second, and the SI system units of momentum are 1 kg into meters per second. Don't forget to subscribe to our channel, and by the way, dynamics will be continued in the next video.